Alright, good evening everybody. I'm creating a short video on how do you find the correct E value for electrolysis cell. So today let's just explain a little bit on how we find the relevant E values for the different equation that we should use for electrolysis. Alright, so let me just do a very quick recap on what are the electrodes that you find in an electrolytic cell. Now, in an electrolytic cell, basically we have a cell notation. Usually the longer line represents the positive terminal of the battery. The shorter line represents the negative terminal of the battery. Now, and if you connect an electrode to the positive terminal, this electrode will have a positive charge. And similarly, if you connect an electrode to the negative terminal, you're going to have a negative charge. So since the positively charged species attract anions, this anions is likely going to undergo, they are going to lose electrons and they are going to undergo oxidation. Now, on the other hand, if you think about the negatively charged species, they are going to attract positively charged cations. And these cations are going to gain electrons from your negatively charged electrodes. So remember, gaining of electrons is actually reduction. Now, important thing that I always share with my student is that which electrodes do you have species undergoing oxidation? Basically, it's the anode. Now, why? Now, a simple way that I can always teach my student to comprehend this is think of two animals. All right. Anode always undergo oxidation. So it's like an ox. All right. Then what about reduction? Reduction always occur at the cathode. So again, another animal, red cat. Follow? All right. So now for electrolytic cell, we can also have neutral species like water attracted to the two different electrodes. So how do we select the correct values for water? Now, very simple. If water were to undergo oxidation, now if you look at this data booklet that I have here, basically when you have the forward reaction, you're undergoing reduction. And when you have the backward reaction, you're undergoing oxidation. So if you want to ensure that water is the only species that can undergo reduction, you just scroll down and you find the only equation that you see water as the only species on the left-hand side. So basically, this is the equation where water undergo reduction. And this is the equation that water undergo reduction at the cathode. All right, what about for equation of water undergoing oxidation? You want to find an equation where water is the only species on the right-hand side. So for this case, you can see that there are actually two equations. You have water undergoing oxidation to form hydrogen peroxide, or water undergoing oxidation to get oxygen. Now, I hope you all understand that hydrogen peroxide is not exactly a very stable species. So we will not choose this equation. That means the equation that we choose for water undergoing oxidation will be the positive 1.23 volts at the anode. All right, so that's it for the equations for how you choose the relevant E value for water undergoing oxidation and reduction. Thank you.